Hello friends, welcome to QLS Quick Learning Students. This is my first video. I'm talking about rigging studies. How to calculate safe working load with the two slings. I'm teaching in this class how to calculate safe working load SWL using two slings. Okay. What required to find SWL safe working load, diameter and length of the wire ropes. In this video, we will find wire rope safe working load and what is the diameter and how much length required to lift the load. Okay. For this, what we need to know before finding of safe working load, we need to know weight of the load. To find safe working load, we have to know weight of the load first. Okay, and we have to know in which angle you are lifting. Okay. Angle factor, actual angle factor. When angle decreases to lift the load, stress of the wire rope increases. That means when you decrease your angle to lift the load, then we should increase wire rope capacity. There are two methods. Actually, see here, if you see this drawing, when you carry a bucket of water with this angle, with this angle, mm, you will lesser energy, you require lesser energy to lift this bucket. If you extend some angle over this hand and bucket angle, if you increase decreases, then you need more strength and more stress, also more strength and more stress to lift this bucket. And same thing, if you lift more height, which with hand and the bucket angle is approximately 30 degrees, that means you can't catch even maybe 5 seconds or 6 seconds also. That means you required more strength than compared to this bucket. In the same method, we are using this angle factor. When you increase and when you decrease, when you keep on angle to lift the load, we required more capacity wire ropes to lift the load. Okay, in this, in angle factor there are two methods. One is general method, one is third party method. Means third party method means in Saudi Arabia there are some third party who teaches you rigging studies. Okay. General method means we can use in both they are charts. It is easy to remember, and they are both are in both methods we have charts. You can see in this chart. First method, general method. See, in this video I teach both the general method and third party method. Both are same, just little bit different. In angle of factor chart for wire rope in lifting, general method. See, if you use 90 degrees, 85 degrees, 45 degrees, 80 degrees, 75 degrees, there are some angle factors here. If you keep your wire rope in 90 degrees, means vertical length, you use only one angle factor, say working load into one. For example, for example, if you keep in 60 degrees, your angle factor is 1.155. In 45 degrees, 1.414. In 30 degrees, 2. Maximum liftings are done in only four angles. One is 90 degrees, one is 60 degrees, third is 45 degrees, and fourth is 30 degrees. In this, we should not go less than 30 degrees. We should not go less than 30 degrees. Okay. This is a general method chart. Now we see third party method. There are for two slings and for three and four slings. Okay. Two slings. First, in this video we are talking about two slings. For 60 degrees load into 0.6, 40 degrees load into 0.7, 30 degrees load into 1. And length of, how to find length of the sling, there is a, if you remember this table, it is easy for you to calculate wherever you can. Okay, length of sling in 60 degrees, the same length of the load means lug length. Okay, lifting capacity, lifting lugs length. Okay, in in 45 degrees there is 71% of load, and 74% of load. Load means lug length. Okay, length of load, and 50% of length of load. Load here also, length of load. In same for 3 and 4 slings, same, but in safe working load, just it will differ here. 0.4 we are using in 60 degrees, here using 0.6. Okay, now you go down. How to calculate safe working load of wire rope? Slings, chain slings, web slings. Okay, this is a general method. There is a formula for safe working load. Safe working load is equals to load into angle of factor. In angle of factor, you can use both general method or third party method. If you use general method, you follow the this table. You follow this table. If you use third party method, you follow this table. Okay, for two slings. First example is for general method in 60 degrees. Okay, 60 degrees. See, this is a load 20 ton, and we have 60 degrees angle of wire rope. Now we want to calculate this capacity, wire diameter, and length for this load. First, we will calculate safe working load. Okay, what is the wire capacity used for 20 ton load in 60 degrees to lift the load? Okay, as we are using the two slings, we should divide it. First, we have to divide, because we are using two slings. In in general method, we have to divide two slings. We have to divide the load by 2 because we are using two slings. Okay, 20 divided by 2, that is equals to 10. As per table, 60 degrees angle factor is, if you see here, angle factor 60 degrees here, angle factor 60 degrees 1.155. Then you multiply SWL is equals to load for one wire rope 10 tons. That means 10 tons into 1.155, that is equals to 11.55 tons. That approximately is equals to 12 tons per each slings. Means this is for 12 tons, this is for 12 tons. Okay, we use 12 tons each capacity wire. In 60 degrees we use two wires of 10-12 tons each. In the same now we use now 30 degrees in general method. General method, load 20, same we take load 20 tons in 30 degrees capacity. Okay, 30 degrees capacity. As we are using two slings, we should divide the load by 2. First, same thing, load is equal to 20 divided by 2, that is 10 tons. If you find, then you have to find angle of factor with this chart table. For 30 degrees angle of factor is 2. That means load, load into SWL is equal to 10 into 0 to tons per each slings. That means 20 tons per each slings. Okay, 10 into 2, 20 tons per each sling. 30 degrees. You then you should have a doubt why this 60 degrees have only 12 tons and 30 degrees have 20 tons for each wire rope capacity. As I told you before here in this diagram, when you decrease your angle, you have more stress and more capacity to lift the load. The same theory applies here. Okay, now you are using now in 90 degrees wire rope in general method. Load is equal to 20 tons in 90 degrees. As we are using two slings, we should divide the load by 2. Okay, load 20 divided by 2, that is equals to 10. As per the table, 90 degrees angle factor. As we are using general method, see in general method table, 90 degrees is equals to load angle is one factor, load angle factor is 1. Then you come here, safe working load is equals 10 into 1, that is equals to 10 tons per each sling. Okay, we use 10-ton capacity for each sling because there is no angle over here. We can use total capacity, what we have wire capacity given on the wire. We can use total capacity. That's why we are using only 10 tons, 10 tons, and 20 tons. We can easily we can lift the load with these wires. Okay. Now this three method is in general method. Now I explain in only general method. Now I will go for third party method. See, same in 60 degrees. Same in 60 degrees. Load is equal to same 20 tons in 60 degrees. As we are using two slings in third party method, we should multiply the load by 0.6. If you see that, if you see this table here, hmm, see in 60 degrees, load into 0.6. In third party method, what we have done load divided by 2, load divided by 2, and for this coming answer we have multiply by say angle factor. But in third party method we should not divide the load. We should directly multiply with 0.6, load into 0.6, then you can get this answer. See, SW is equals to 20 into 0.6, that is equals to 12 ton each wire rope. If you see here in general method, you also got same answer, 12 tons per each slings. That means 11.55 tons, that approximately is equals to 12 tons per each slings. In if you see in third party method also, you are getting same answer, 12 tons per each sling. Now you decide which method you can, now you decide in which method you can remember and which method you can do. Okay, uh, you can do calculation. Now in third party method, see 30 degrees, 20 ton load in 30 degrees. As we are using two slings in third party method, we should multiply the load by 1. SWL is equals to 20 into 1, that is equals to 20 ton each wire rope. Okay, if you see the table here or here, if you see the table over here in a third party method, 30 degrees load into 1, that is equals to 20 tons in third party method. If you, okay, if you see, if you see in general method in 30 degrees same, you are getting 20 tons per each sling. Okay, now let's go. Now how to calculate. Hmm. Now, this is a calculation of safe working load. Mm. Now we will go for how to calculate length of wire ropes. Length of wire ropes. In this also there are two methods. One is general method. One is third party method. Third party method is already indicated in this table. I will show you. And for general method, there is a formula for length of wire rope, sine theta into length of lifting legs of load. Lifting legs mean one leg, two leg. There are lifting points of load. You should see the how much meter distance you are two lifting legs. I indicated here 4 meters. Same 20 ton load we are using in 60 degrees. Then sine 60 degrees is equals to 4. 4 means this lifting lug length 4, that is equals to 3.46 meters, approximately 4 meters. Now we need each wire rope length is 4 meters. 4 meters. Okay. Uh, for blind remembrance, in 60 degrees right angle triangle, all sides are equal. That means if you use 60 degrees in 60 degrees angle wire ropes, wire rope using in 60 degrees, then 4 meter, if you have leg length is 4 meter, you have to take two wire ropes with 4 meters. It is a blind remembrance, means in this is a right angle formula. If in all sides are equal, then all angles are also equal. Okay, same example in sine 30 degrees into 4, that is equals 2 meter. Sine 30 degrees into 4, that is equals to 2 meter. Wire rope length. Okay, same. It is general method. For as per formula, sine 30 leg length of a 4 meter, that is equals 2 meter. That means we have to use 2 meters. In 30 degrees we have to use 2 meters length to lift the 20-ton weight. Okay. Mm, Now example number 8, we are in 45 degrees, sine 45 into 4. If you have an angle of 45 degrees, sine 45 into 4, that is equals to, if you see here, 2.828 meter, that approximately is equals to 3 meters. Okay, that means we are using 3 meters wire rope in 45 degrees to lift the 20-ton load. This is general method. Now we have to use length of wire rope in third party method. How we can calculate? In 60 degrees, as per table you see above, in 60 degrees, same length of the load, that is equals to 4 meters. Okay, same length means lifting leg length, that is 4 meters. Then wire ropes also should be in 4 meters. In 45 degrees, about 71% of load length, that is equals to 4. 4 means leg length 4 into 0.71. So 71% means 0.71, that is equals to 2.84 meters. Approximately is equals to 3 meters. If you see above in general method also, 45 degrees and 45 degrees, in 45 degrees angle you got 3 meters. In same in third party method also, in 45 degrees if you are using, you got 3 meters. Okay, now in 30 degrees, about 50% of load length, same, 4 into 0.2, that is equals to 2 meters. If you see above, we are using here 2 meters, same in this also we are using 2 meters. Okay, whatever formula is, whatever method you are using, answer is getting same, but now it's depend on you, which is easy process, and how you can remember these things. Okay, now let's go for another topic, how to calculate the diameter of wire rope slings. Now you have to calculate the diameter of wire rope slings. For the we have to calculate diameter for wire rope slings only. For chains and belt, there are already indicated on the load. They have tags already indicated, and in wire ropes also we are already indicated. But for blind remembrance, for blind remembrance, we have a formula to find out a diameter, that is equals to, diameter is equals to root over safe working load by 8. Safe working load already we have calculated before in starting of the video. I write here already, calculate safe working load of each wire rope. 60 degrees is 60 degrees 12 tons, 30 degrees 20 tons, in 45 degrees 15 tons. Okay, now we will calculate diameter in same 60 degrees, 45 degrees and 30 degrees. For example, this is example 9. In 60 degrees, root over, in 60 degrees how much we got? 12 tons each capacity of wire rope. That's 12 tons, root over 12 divided by 8, that is equals to 1.22 inches. Answer got in inches. Now we have to convert it into an mm. That's 1.22 into 25.4, that is equals to 30.988 mm. That approximately is equals to 31 mm diameter. Okay, 31 mm diameter. Now you should not take a lesser diameter than 31 mm. You should take a higher capacity diameter only. Okay, this is a minimum diameter you should use in wire rope in 60 degrees. Now in 45 degrees, root over 15. 15 means SWL. What, how much we got? 45 degrees in 15 tons. 15 divided by 8, that is equals to 1.37 inches, that is equals to 1.37 into 25.4, that is equals to, you got 34.798 mm, approximately is equals to 35 mm diameter. In 30 degrees, if you same calculate root over 20, say working load 20 divided by 8, and 30 degrees 20 divided by 8, 1.58 inches, that is equals to 1.58 into 25.4, that is equals to 40.132 mm, approximately is equals to 41 mm diameter. Now you got an idea how to calculate safe working load, uh, diameter, how to calculate wire rope diameter, and how to calculate length of wire rope, slings, and everything. You got an idea. Okay. Safety factor. What is safety factor? Actually, this is not with this topic, but I'm explaining regarding safety factor. What is safety factor? Factor of safety, FOS, certain, create a margin for uncertain in a case of unexpected excess force or malfunction. Formula: factor of safety, Fs, unlimited load by allowable load or design load by normal load. For example, if you are using a wire rope of 30 tons, 30 tons, that means company manufacturer, this wire is tested on approximately 4 times higher capacity. Means this was tested on maybe 120 tons, 120 ton capacity. Okay. Now, after testing in 120-ton capacity, they given a denomination, they given a tag that we can use in 30 ton. That means we have a allowable load, means safe working load is 30 ton on wire ropes. Why they given like this? When he was tested in 20 tons, 120 tons, and after in when you are giving a certificate, they are telling that we have to use in 30 tons only. Why? Because when we are lifting, when we are lifting a load, some uncertain force will come, like there are vibration, jerkings, everything. In jerkings, if you use a 2 ton load, if you have a vibration, this 2 ton will convert it into 10, means 5 times, 6 times higher capacity. For example, if you have a vibration over here for 2 tons load, it will turn to 10 tons, 20, 15 tons more, some cases in 15 tons, or because of gravitational force. That is why, because when you lift maybe 20 tons capacity over here, if have some jerkings, some vibrations, the 20-ton capacity load easily exit this wire rope capacity. Because of the, because to withstand the vibrations, this company manufacturer will test more than 4 times higher capacity. Okay. Okay, I think you got an idea what is a safe working load, what is diameter, how we can calculate diameter, how we can calculate a length. I think you got an idea in this video. Thank you for watching. If you like this video, please like and subscribe. I will make you next video for hitches and everything, how to calculate hitches. If you like this video, please subscribe and support me. Thank you.